Okay. Let me take you to the Mission Impossible. Let's go 1 year back, 1 year minus 1 day. Let's go to Sweden, let's go to Eskilstuna. Let's go to a bar, and let's go be late in the evening to a bar. There have been 2 people met in this bar and start to talk about crazy ideas. And what happens mainly when you talk with some drinks about crazy ideas? It was nice, and the next day and see it. But hey, we are standing here. And that's what we talk about.
What will we present you for the next 25 minutes? The project, the equipment, the energy supply, our learnings, our failings, and our vision and mission. Yeah, the world first fully electric deconstruction site.
And you want to know after if Michael can pay a beer or another drink after this project. You want to know what happens now to your diesel machine, and you want to know if you are really that genius as you look like. Well, we can tell you. Next step in the Mission Impossible is we change location back to Germany. We are now in the Siemens project in Erlangen, which is like 2 hours north from Munich or 2 hours east from Frankfurt.
And in the middle of Bavaria, we find a good partner for our project, Siemens. Between Siemens and my company, Metzner Recycling, there is a trustful partnership for over than 20 years. You see the building which we have to destroy in the red frame. And yeah, we take down the building to the surface of the foundation slab. We have 3 months time for dismantling inside and for the construction of the whole building. And we have to handle 10,200 tons or mineral waste. And we have the target to arrange a recycling rate of 96%.
Yeah, and now the problem started because out of our crazy idea, where we start in the pub, we talked to our customer, and all of a sudden we had the problem because we have to do it. So how to start that story? The first thing we have done was really talking from my side as a machine supplier to Michael, as the company, how to do this job really in detail. And that was really important for that journey. We really said, okay, we go with that machine on that side, we go and work in this direction, we take the material away in the other direction, to have a really good mapping and planning of the site itself. Then we started to discuss which machines we need and with what machines we can do this. When that was figured out, we could calculate roughly the energy consumption needed. And then we had to make new friends. Things we have never done before. We talked to the grid owner, we talked to that electrician guys which doing this 20,000 volt connections. We had to find other suppliers for crushers, for whatever, that we can do this job. Based on that, we could really do a layout of the job site to avoid cable crossings, to have a proper routing of the cables, to make this job site safe. Because just imagine, it was the first electric site. You could imagine that everybody was focusing a lot at what you are doing, how safe you can do that. And we have been in contact with the safety inspector, with the insurance company, with everybody from the beginning to say them or show them, hey, it looks like this. We go with the cable to this tunnel. We go underneath this gravel way we have done. And the complete planning is that material flows not where the cables are. So safety, that was here the big story. And then we start to work.
We used 2 Husqvarna robots, which are connected to the grid. And with these robots, we do dismantling the inside of the building and destruction inside the building. The robots are radio remote controlled. And yeah, we used with different attachment. We also have a compact loader, the Volvo, and with this loader we handle the material and we transport the material. And we also use a compact excavator, which we use inside the building for dismantling and also outside. And it's a super machine because we have no issue of exhaust, and this gives us new opinions for work inside the building to make work which we do before by hand. And with this machine, we were very happy because the operator learned a lot of things we can do with this machine inside the building.
Well, and the next level of machines, we are used, of course, bigger machines to bring down the building itself. We had that wheel excavator, you can see, 26 ton with the material handling equipment, grid connected for the main demolition work, attached with all the equipments you can name it. We had them, breakers, concrete cutters, shears, magnets, everything. As well, we had a crawler excavator, 23 ton, battery driven, which was used for demolition, cleaning and material management, and to feed the crusher. Furthermore, there was that L120, which is a 6-ton metric loader, where we did the material transport from the actual demolition area into the recycling area, which was close by, like 100 meters, but we had to manage this as well. The other thing we had in the terms of electrification, because we said all in or nothing, was trucks. We had one electric hook lift truck, which was constantly in use, we can say, for all the material management and the sorted materials to drive in, out, all the scrap. By the way, it was like 500 tons of scraps we carried out, metal scrap we carried out here. And beside this hook lift truck, we had a tractor trailer truck for machine transport, as well as the usage with a dump trailer for material transport. So the complete logistics, I would say 90% we could do electric with the equipment we had.
We also use a mobile crusher on the side. Here is a Claymont crusher. With this crusher we produce around 200 tons of high quality recycling material, recycling mixture, which are reused on the new buildings surface. The Claymont crusher is connected to the grid and directly to the transformer. And we also use a mobile screening plant, which is also 100% electric, connected to the transformer. With this screening plant, we produce concrete chipping, which we give directly to the new concrete for the foundation of the new building.
Well, and then something, just we wondered ourselves, to be honest, because I came to the job site and all of a sudden there was an electric crane. So why are we showing this picture? It was not by us, it was the job site manager that starts to play the game really, and the task was, can we really go all electric? And all of a sudden they came up with that hybrid version of a mobile crane. So the chassis is diesel driven, so they came into the job site, switched off the diesel engine, connected it to the grid, and the crane was working completely electric. And the thing is, to show here, there is more electric equipment out, as you probably think, or probably know, because we have been wondering ourselves what we have done there. Talking about electric, now the question everybody is asking about electric sites, what is about the infrastructure? Here we rank different concepts against each other. And was the idea to get electricity from the plant, or we have to go in the road and connect directly to this mid-voltage net, which is 20,000 voltage. We did a ranking and decided actually to go to the road directly. And maybe one word here. Of course, here it fits and it was okay, and not in general everywhere you have these possibilities. But an easy logic by electric demolition. If you say there is no infrastructure, just think about how was the plant or that building supplied by power before you demolish it? Had they candles to get light? I don't think so. There is power. It's just a question of planning. We had that transformer that goes in with 20,000 volt, transformed it down to 400 volt, mid or low voltage net, and that was the infrastructure on the job site. So we connected the charging pile to 400 volt, the crusher, the grid-connected wheel excavator, and all the other charging solutions. and drive the story by this. What you can see on the picture is on the left and on the right side, there are small trenches refilled by gravel. This is actually on, from your side, the left side, where the 20,000 volt going in, and on the right side, where partly 400 volt going out to the crusher. So where we could, we put all cables into the ground. And that's not a big job. I mean, companies like here making a trench and put some cables in. The positive thing, we are safe. The cable which is in the trench, you can't destroy. You can run over it by the truck. Who cares? By the crawler excavator. So safety, safety, safety.
Yeah, but now we are talking enough. Let me show you what we have done on the site. You see the structural deconstruction of the building. And for this job, to drop down the house, my team need 8 weeks. Yeah. What we have learned, the operator are open mind for the electrical machines, but they're a little bit skeptic, but the machines, the electrical machines, have the same power and performance like the diesel machine. It's similar. And the best advantage for the electric machine is the low noise level inside the building, no exhaust fumes. The charging was not a problem during the building, during the job, because we have a learning curve. The operator have to learn the first 2-3 days that they have to charge the machines, the battery-driven machines, during lunch break, when they clean the crusher, and they didn't use the machines, they can charge them. And yeah, uptime. We have no problem on the site. We have no problem with the equipment or with the machines. And the best thing is that we have no safety issue during the whole job. Everything run very well, and we have no accident. Any failures? The CO2 surviving achievement, we have 70 tons. And it was not a showcase, it was a real contract between Metzner, my company, and Siemens, where we have to finish in time, and we do that in time.
But what we see, there is potential. Are these failings? Maybe. So for instance, what we learned in terms of maybe inefficiency, I would say, we presented this transformer we installed on the job site, which is a mobile one. But what we tried was somehow to align with the building guys coming after the demolition, because they need energy as well. The first thing they do is they build up the tower cranes that they can start to build the building, right? And they need to be powered by electricity. So normally the first thing is they build their own transformer, and we wanted to align with them that we found a place that we can place the transformer and use it for the demolition, and they can use it and actually for the building to be efficient and save money. But that was a kind of impossible. That was, we don't know actually how do we, where, what to build. And then we wasted money by this just because we said, okay, if you don't decide, we decide where it is. And even there, it's what I said before, there is energy in the building. And normally before demolition starts, the first thing happens, everything is cut off, that it's safe. But if you think a bit about this, and in the planning it would be considered that, okay, this transformer or whatever we can use, then it's possible to do. That's the thing we learned. The other thing I want to talk is about 70 ton CO2. What the heck are 70 tons CO2? In our job site, we saved close to 23,000 liter diesel, or close to 6,000 gallons of diesel, which we didn't burn on this job site to drive the machines. That means if we didn't burn them, Michael haven't to pay them. Of course, we needed electric power, this is for sure, and we burned electricity, this is clear. But if you see the ratio between a gallon of diesel and the price for a kilowatt of energy, definitely that plays for our site. And there is some cash flow that is in the positive direction in his pocket when we play that game. And that brings us to the next point, the commercial learnings you probably wait as well. So we saved the infrastructure, It's not the biggest deal, and all that mobile transformers and stuff are there. Now we come to the commercial aspect.
100% electric operation. We do 96% recycling rate, and we do 15 till 30%.
Yeah, commercial learnings. 50 to 30% less idle time on the machines. And why I'm starting now by commercial learnings talking about idle time. On the diesel machine, if the machine is idling, your operator jumps out, need to fix something, need to take something, the engine keeps running. And that means your hour meter keeps clicking. If you have an electric machine, you stop working, the engine stops. The electric engine, the motor stops to work, and the hour meter stops to click. And that has been, that is a rough calculation. It depends a bit. Honestly, we have cases where we see it higher and a little bit lower. So the 15 to 30 is a good average. The thing is, if you have 15 to 30% less hours on your hour meter, there is a financial aspect. Because if you resell the machine afterwards, these hours are not on your hour meter. This is positive in your pocket. And if you calculate it to the service you need, the every 500 hours service, as well there is an effect, right? If you calculate it by 2 years, there is one service saved. This as a commercial aspect. 11%, the next figure. This job site we have done here was below 11% additional cost. Our first time use case, which was here and there as the example with the transformer, not the most efficient, was below 11% cost. And the next figure is 8%. And we are 100% sure we can make an electric demolition site below 8% additional cost to the total volume of the contract. Is this black and white? Is that the ones that change the world? No. But we can showcase here that we not can say, it's double the cost, forget about it. These are figures, at least we learned on our job site.
Yeah, but by all the figures, the most important thing is the team. We have a big team of a lot of companies, which each team member work together and learn from the other. And this makes the project such a success.
And then we come to the mission and vision, our summary. So, back to the beginning. What happens to your diesel machine? Keep it. It's okay, no problem. Will we see from now on only electric demolition sites? Not at all. Will it be everywhere possible? No. No, it makes no sense talking about a bridge demolition somewhere out on the highway to electrify. This is for sure. This is 100% sure. So, relax.
Yeah, from the project side, it is possible. From the equipment and infrastructure side, it's possible. And from the financial side, it's in an achievable rate.
The thing is, we are saying it's not everywhere possible. And still it's then the question, okay, what the heck, why should we use this? Change a bit your perspective. Go into a global view. There are regional differences. The situation in the US is different than the situation maybe in Japan. And then the situation in Europe is again different. And then even in Europe we have different situations country by country. So we are in a situation in between, we don't need that, in where we have the discussion that countries by laws and regulations say you have to do it electric without any emissions. We can think about demolition inside buildings, as we had the compact equipment, right? Otherwise, you have to see that the air change and everything is going. But here, no problem. If you think about inner city demolition, and Michael can tell you nice stories about that, if it's really, like in Germany, quite tight and everything is there, and all the neighbors are screaming about the noise at 7 o'clock in the morning, and you get restrictions that you're just allowed to start 8:30 because the machines are too noisy. If you take all that things in account, maybe it pays off if you pay a little bit more for the electric story. And then you have less effort and actions and issues around this because you do it more sustainable and more acceptable, I would say, for the neighbors, saying it in that words. One thing is clear, that story will be continued. And saying that, the question to you is now, do you have any questions to us?
Dankeschön. Thank you very much for the presentation and also for what comes out of a bar. That's always nice. I'm going to challenge you, so just bear with me. Because you said it's almost 100% electric demolition, but you know, for that you lost a lot of energy to use hydraulics. How about, did you consider, you know, electric, everything, electric attachments, electric, everything else, or that's not yet on the horizon for Volvo?
Okay, from that side, from Volvo, that's a good point. So what I can say here is that electric machines are in our focus, and I need to be careful. And of course, all diesel machines are in focus. Don't be scared, we still have them, big diesel machines. But on electric machines, the drive that we see from Volvo is to gain efficiency on the machines. And why should these machines efficient? As less energy you consume, as longer you can work on the battery. Or as lower are the requirements to be connected to the grid. So as less energy you need, it's easier it is to use. About efficiency and tools, we did on the job site a nice tryout, and that was more by accident. That was, we had three different concrete cutters. And we just thought, why not testing? Because one concrete cutter, I don't say the name, was with a power boost inside. The other one was a bit different jaw, and the other one was like a standard one. And we said, let's try how efficient which concrete cutter is working. We had a nice opportunity with 3 different same fields in a floor to cut it out, to see where we can save most energy to be most efficient. That was one thing we have done here. But we are, of course, in contact with the attachment suppliers and try to find solutions. But to say my perspective, that might be wrong. There are tools, electrification is perfect or super easy to do and efficient. As, for instance, on a concrete cutter, that might be a way to go till we get that power and that compactness in that place, like on a high reach, like 36-meter height. More questions? You are shocked, that's good. So electric. I saw we can electrify you a little bit here.
One more here.
It was really good to see zero emissions, particularly when people are doing soft strip in buildings using and mini excavators that are not zero emission machines. I really hope that you controlled conventional safety, like with respirable crystalline silica, because in the UK we're killing 1,500 people a year from that. I did see the guy with the hose. That worries the something out of me when I see an excavator in close proximity to the guy holding the hose. I'd much rather see a fixed dust boss or a machine piped with dust control. It's just an observation. Look, I'm not being picky. I just want to protect boys and girls that do a difficult job, especially in soft strip, ragging down ceilings, pushing walls over. But I applaud, because I was in Stockholm, and well done, fellas, full electric, I love it. But just make that observation for the next one.
For the next one, thank you, sir. Okay, but then, some more, yeah.
Good afternoon, Vincent Mijotte from Caterpillar. I wanted to know, was that a requirement from Siemens to be carbon neutral on that job site, or was your crazy idea just to prove the point to be fully electric?
So I was like that, where we start for the crazy idea, let's say like this. And then Siemens was more than open because they haven't known that we can do this or that Metzner Recycle can do this. And by just offering that, they have been more than arms wide open to say hello to this. What we can say that out of that job site, there was a lot of requests and discussions about, and we can say it will be continued. We know already now, definitely.
And maybe a following question is, was Siemens ready to accept a higher bid because it's fully electric or carbon neutral compared to another?
No, we in real life, they didn't accept.
Thank you.
Okay. But then, okay. Thank you very much.